This is our Key Stage 3 revision burst on chemical reactions. There's going to be two more after this that are going to focus on equations and balancing equations, but this one we're really just going to look at getting the basics in place. Okay, chemical reactions. When we talk about chemical reactions, there's a few definitions you really need to be fully aware of. Two of those words are on the screen now: reactants and products, and in between those two you can see there's a red arrow, and that's really important because that tells us a chemical reaction has taken place. Please do not be tempted to replace it with an equal sign. Now, our reactants are what we start with. They're our substances that we're going to join together, and the products are the substances that get made. Now, let's have a look at one in particular: magnesium and hydrochloric acid, and we're going to react them together to produce magnesium chloride and hydrogen. Now, you will have done this in the lab. You will have taken some hydrochloric acid in a test tube and dropped some magnesium ribbon, which is a thin silvery ribbon, inside it. You will see some hydrogen gas given off, which is your evidence of a chemical reaction, and the magnesium would have disappeared because it will have formed magnesium chloride. You wouldn't see the magnesium chloride because it would be dissolved in the liquid in the test tube. Now, this representation is our word equation. The substances are represented with words. There's no chemical symbols there at all. It is our word equation. We could draw a symbol equation. This is our symbol equation, and what happens here is each of the names of our substances has been replaced by the symbols that you would find for those elements on the periodic table. Okay, we will do a whole revision burst on symbol equations and how to balance equations, because getting the numbers, like you can see there's a big 2 before the hydrochloric acid and a couple of small 2's in the products, getting those correct is essential when you're talking about symbol equations. Okay, let's think about these chemical changes that are happening. Now, there's two sorts of changes: chemical and physical changes. We really need to make sure you're clear which are chemical, which are physical, and that you don't get them mixed up. Now, chemical changes. When we cook an egg, we get some changes happening. Those changes are irreversible. You can't uncook an egg once it's happened, and these changes are because a new substance has been made. Okay, so when the egg cooks, you can see there's a color change, the texture changes, the changes are irreversible, and basically a chemical change has taken place. Now, physical changes are quite different. They are reversible. And if you think about things like, for example, changes of state, melting, boiling, evaporating, condensing, they are all reversible reactions. And so, for example, think of ice melting. You can reverse it. Once it's turned into water, you can actually put it back in the freezer and it will turn back into ice. They are called physical changes. Now, when chemical changes happen, there is always evidence, and you need to be really familiar with the different types of evidence that you are looking for to see if a chemical change has taken place. Now, these are things like smell, temperature change. You can often get a lot of heat given out, or you can get heat taken in. You can get a drop in temperature when a chemical reaction happens. Sound, you quite often get some crackling or some fizzing or even some hissing and some whistling depending on what reaction is taking place. You can get flames and sparks. Think about fires and fireworks. You can actually get evidence that is very, very visible, quite exciting ones. And you can also get colour changes. Okay, so these are our evidences. You need to be able to list these 5 types of evidence, perhaps give some examples of each one. Now, I've given you a little picture in the bottom left-hand corner of a fire that's actually used to heat our houses. Now, burning, combustion of that wood is a chemical reaction, and the evidence that you'll see is a huge temperature change. We of course use that heat to heat our houses, and flames and sparks that you see, they're also given off. So that's our evidence of a chemical reaction. Okay, now let's have a look at a classic reaction that we use to sort of describe differences between elements and compounds, and loads of evidence that a chemical reaction has taken place. Now, it's iron and sulfur, and you've done this in the lab. Okay, there's our word equation. Iron plus sulfur gives iron sulfide. And then, of course, we've got our symbol equation. Fe plus S gives us FeS, which is the symbol for iron sulfide. And if you think back, we started with some iron powder, which is our black powder, and some sulfur powder, which is a yellow powder. And then we mixed the two together in a test tube and heated it and produced this lump of sort of grey solid, which is called iron sulfide. Now, our evidence that a chemical reaction has taken place in this example is there's the colour change of the sulphur. It's gone from that lovely yellow colour to a sort of grey solid, and the iron initially was magnetic, but when it's in the form of iron sulfide, it's a different compound and it is no longer magnetic. Okay, we can use the particle model to describe these changes. And we would draw it like this. We'd draw our iron as blue particles, and then our sulfur perhaps as red particles, and then when they are chemically joined together after our arrow, so when they're in the form of our products, then we would draw them with these red and blue circles alternating. So we've clearly got a solid structure there. We've not got a mixture. We've got a nice solid, and it's a regular arrangement, and we can also add underneath our symbol equation to show what each of those colours represents. Now, that's really the end of the basics that we need to cover. A couple of examples of things in there. I'm going to run a little quiz next, so I'm going to ask you some questions. After each question, I'll leave a 4 or 5 second gap just for you to think of the answer. You can either write it down on paper or you can say it to yourself, whichever suits you. I know you like to do them differently. And then we'll go through those questions and then you can move on to the next revision burst. Okay, so question number 1 coming up now. What symbol is used to show that a chemical change has taken place? The answer is an arrow. Of course, there we go. Question number 2. Give 5 pieces of evidence you might see for a chemical reaction taking place. Okay, looking for 5 pieces of evidence. Okay, here we go. So, smell, temperature change, sound, flames and sparks, and colour change. Sometimes you get combinations of those happening. Sometimes you may get, like, very slight smell or maybe a very small temperature change, but there's usually some evidence that a chemical change has taken place. Okay, question number 3. Give an example of a physical change. Several examples you could use. Give an example of a physical change. Okay, you could have had melting or boiling. Evaporation would have been one. Condensing or condensation would have been one. Solidifying, you could have had that. Any of those would have been absolutely fine for a physical change. They are generally known as our changes of state. Okay, question number 4. What does the word reactant mean? What does the word reactant mean? Okay, and here we go. It's the substances that you start with before a chemical reaction takes place. So it's the things on the left hand side of the equation. It's what you start with before your chemical reaction takes place. Okay, question number 5. What does the word product mean? What does the word product mean? Okay. And here we go. It's the substance or the substances that get made in a chemical reaction. So that's what you actually get produced at the end. Okay, that's what you get left with. Things on the right hand side of the equation, it's the substances that get made. Okay, question number 6. What experiment did the slide use to demonstrate a chemical reaction? So a few slides ago, what experiment did we use to demonstrate a chemical reaction had taken place? Classic experiment. The answer is iron plus sulfur gives iron sulfide. That's the iron sulfide experiment, and we all use it to demonstrate the difference between elements and compounds and to demonstrate chemical reactions have taken place. Okay, question number 7. What properties were different about the products and the reactants in that experiment? Okay, so have a little think about it. What properties were different? So we had our products were quite different to our reactants because our chemical reaction had taken place. What was the difference? Okay, here we go. So our iron was magnetic and a black powder, that was before. Our sulfur was a yellow powder, that was before. And then afterwards, our evidence was that they changed because the iron sulfide was not magnetic, so there'd been a change there, and it was a grey solid, so we'd lost our sort of yellow and black colour. Okay. Final question. How can we show this change using the particle model? How can we show the change using the particle model? And here's our answer. Right, we can show each reactant as a different colour particle. That's important. Make it clear which ones are perhaps iron and which ones are sulfur by using a different colour. And then also show the particles separate before the reaction and then join together and alternating in their order after the reaction. So there we go. So we have our iron particles shown in blue, and then we represent the sulfur particles in red and then show them as iron and sulfur mixed up together, but still in a regular order because it's a solid, as our iron sulfide. Okay, well that's the end. If you want to go on and do the revision burst for the word equations and balancing equations, that would be a great idea. Or if you think you still need to practice these a bit, then replay the second half of this video and practice your questions a little bit more. Okay, thank you.